Okay, I think we're good to get started. We are going to be working our way through this handout. This will be the classwork for today, and the homework worksheet for those of you in class, I'll pass that out towards the end. Those of you at home, it's already posted in Google Classroom. All right, for this classwork here, we're going to be looking at rational expressions that have similar structure to what we've been looking at the last 2 days. But now, instead of being specific numbers, we have just generic ABCDs. So for all of these guys, ABCDs, they represent distinct non-zero integers. So they're all going to be different. They're not going to be zero. And just to keep it clean in terms of the discussion, no fractions, no decimals. So how much can we tell about this graph? So one thing that we would be paying attention to, or hopefully paying attention to, is the x minus d's cancel. So what are we left with if A, B, and C are just regular normal constants, or just numbers like 2, 3s, and 5s? Okay, what does that graph look like? Well, that would leave us A over B times x minus C. And if we clear parentheses, A over bx minus AC over B. Okay, that's just a number. That's just a number. It's an equation of a line. So what we have here is, if we had to just classify this, this is a linear with a hole. That hole is going to be at x is equal to d. Sorry about that. Let me zoom back out. Now, if we wanted to go a little bit further in terms of describing the key features of the line, the slope of the line would be A over B. The y-intercept of the line would be negative AC over B. All right, so here's the deal with these questions. They're specifically designed so you can't answer them, or it'd be very difficult to answer them by looking at a picture on your graphing calculator. You're forced into understanding how does the algebraic structure of the particular expression lead to the features of the graph. Now, this is a very, very open-ended worksheet. What can be determined? Really hard to know. Well, when do you stop determining things? Okay, we're just going to stick to each one, some of the more obvious questions, or some of the more obvious features you should be paying attention to. For the quiz, there'll be very specific questions. They'll be like true, false, like that's a linear with a hole. Or describe this graph, linear with a hole will be one of the options with several other things. It's not going to be a just keep writing about it until you run out of imagination. All right, we good with number one? All right, let's take a look at number two. Got f of x, a, x minus c, x minus d, b, x minus c, x minus e. All right, for this one here, I want to start off with, let's identify the domain. Okay, our domain is all real numbers except for when the bottom of the fraction is equal to 0. Well, b is just some constant. So b is never going to be 0 because it specifically said non-zero in the instructions. So that's going to be 0 when c is when x is c. That's going to be 0 when x is e. So we have two restrictions in a domain. X cannot equal c. X cannot equal e. All right, now what's happening at those restrictions? Well, the x minus c's cancel. So what does that tell us we have at c? Hole. So we have a hole at c. Okay, the x minus e did not cancel. What do we have there? What kind? Vertical, very good. So those are some quick things we can identify about this graph. Now, it still has that x minus e on the bottom, so it still has that general rational flavor to it. So another thing to examine would be, does it have a horizontal asymptote? What would the degree of the top be? Degree of the bottom is, does 1 equal 1? Yeah, so the degrees are the same. If the degrees are the same, it's going to be the ratio of the lead coefficients. But what are the lead coefficients? A and B. So we have a horizontal asymptote that y is equal to A over B. Yes?
So wait, how are they both, like, are they both x squared?
Well, it doesn't matter whether you compare the original or the simplified. You either be comparing 2 to 2 or 1 to 1. I guess I should have been more specific with the opening question. The simplified version, the degree of the top is 1. The simplified version, the degree of the bottom is 1. If we looked at the original, it would have been 2 to 2. But you can use either comparison. You're welcome. All right. X-intercepts. Is C an x-intercept? No, if you're a hole, you're nothing else. Okay, we've already classified that's got to be a hole. How about D? Will D be an x-intercept? Yeah, that's what causes the top of the fraction to be 0 in the simplified form. So we have an x-intercept at D0. Okay, y-intercept, this would be a little bit icky. Y-intercept is when x is 0. Now, these are already gone. Not going to worry about that when it comes to identifying the y-intercept. We'd be left with negative AD up top, negative BE on the bottom. So it would just be AD over BE. Not the cleanest looking y-intercept, but we could find it. All right, how about a slant asymptote? Will it have a slant? No, you can't have a horizontal and a slant in the same problem. Slants are only going to happen if the degree of the top is exactly 1 more than the degree of the bottom. So in terms of that kind of big list of things we had for most of the questions the last couple days, domain and range. Domain, very, very difficult. Hello.
Anthony Burton.
Oh, right there. Oh, I didn't say none of what. Just none. Slant asymptote. All right. I forgot what I was saying. Oh, the big list of everything we identified. So domain and range. Range would be really, really icky. You're not going to have to worry about range for something like these algebra ones. With domain, you can identify. X and Y intercepts we did. Vertical asymptotes and holes. Horizontal slant asymptotes. So that would be kind of a little bit of everything that we talked about over the last couple of days that we could identify with that. All right, number 3. I'm sorry. Let me give you the worksheet so you don't have to print it out at home. Where'd it go? Yep. Oh, I don't know if I said this or not, but just one more thing to emphasize from this one here before we move on to number 3. Always make sure you identify a domain before you reduce or cancel. All right, how about number 3? Is anything canceling out here? No. So our domain for this is x cannot equal e. Okay, what do we have at E? What's going on there? Vertical asymptote, perfect. Okay, for the type that we're doing, It's only going to be one of two things. It's either going to be a vertical asymptote or it's going to be a hole. If it's not canceling out, it's a vertical asymptote. If it cancels out, it's a hole. Next unit, I was saying next week when I was talking about next unit, the next unit is actually going to be after break. After this quiz, it'll be reviewed for the quarterly. So after break, when we start the next unit, we're going to examine some other possibilities of what could happen. All right. So we identified the domain, what's going on at that restriction. Let's go to the horizontal asymptote next. Okay. Do we have one? No, you shook your head first and I was looking at you. What's the degree of the top?
2.
What's the degree of the bottom? Is 2 bigger than 1? Yeah, that means there's no horizontal asymptote. Now, if there's no horizontal asymptote, we'd have to ask the question, is there a slant? Still your show. Okay, if the degree of the top is exactly 1 more than the bottom, the 2 is 1 more than the 1, then there is a slant. Now, finding it in this form, that would be cruel and unusual punishment. We'd have to multiply that out and then divide it using long division, and we'd have coefficients that were like extremely unpleasant. You wouldn't be asked to do that on the quiz. You wouldn't be asked to do that ever. Not in a house, not with a mouse, not in a box, not with a box. Okay. You should identify, yes, there is a slant asymptote, but there's really no reasonable way to find it. So for slant asymptote, we're putting yes. All right, let's go to intercepts next. All right, someone raise your hand for this. How many x-intercepts we got? What do you got?
3.
Did you go with 3?
Oh, no, actually.
2. Okay, which 2 are they then?
X minus C and X minus C.
Yeah, but you got to give me a specific letter. What will cause x minus c to be 0? X would have to be?
C.
Perfect.
And
D, I'm hoping you're going to say. Did you say D? I don't know.
yeah.
Okay, I was thinking in my head. I started writing it, but I wasn't sure if you actually said it or not. Okay, were you thinking A when you said 3?
Oh, the 3, but then you say it can't be.
Yeah, because A is a distinct non-zero integer, so A can't be 0. All right, y-intercept, plug in 0 for x, so it's another one of those messy ones. I'm not going to write it down. It would be A negative C negative D over B negative E, and then the negatives would cancel. If I asked you a y-intercept question on the quiz, it would be something that would be like cleaner than that. It wouldn't be big and messy. All right, so domain, we're not going to be doing range. We got the intercepts we talked about, the horizontal slant asymptote. We've already identified it's a vertical asymptote. It's got no holes. I don't think there's a whole lot else to say about that. I think that's pretty much exhausts 3. Oops. All right, someone want to volunteer to answer these questions without knowing which one I'm going to ask first? Anyone brave enough in here? Jennifer? Okay, good, not the other one. All right, Jennifer, tell me, do we have any restrictions in the domain? Perfect. Oops, you said F and I wrote E. I'm already messing you up. All right, tell me what's happening at F. Is that a vertical asymptote or a hole? Very good. And we know it's a hole because that is canceling with that. If that x minus f did not cancel out, then we know it would be a vertical asymptote. All right. Now, what are we left with here? That x minus f cancels out. How would you classify this graph? Close. What would the degree of the top be after that's gone? 3. Okay, what's a word for a third degree? Begins with a C. CU.
Cubic?
There you go. Okay. So the best clean classification we could give this would be it's a cubic with a hole. So this is a cubic with a hole at x is equal to f. So that would be like a typical question on the quiz. They would give you that original expression and say, which of the following best describes it? And one of the options would be cubic with a hole. Or removable discontinuity. I don't remember what term they used on the quiz. All right, still your show. How many x-intercepts does our cubic have? Very good. List them off to me. What are they?
C, E, E.
Perfect. All right, the y-intercept would be negative ACD over B. So not really going to go there with that. All right. I think that probably wraps up number 4. All right, someone who hasn't answered one yet. I want to go through the everything we know. Let me copy this down. About number 5. All right, what do you got there? Well, actually, I'll direct you here. First, tell me what are the restrictions in our domain? Okay. What's happening at G? Perfect. Because that cancels with that. What's happening at F? What's happening at D? Perfect. Oops, sorry. So that's our domain. All right, how many x-intercepts is this graph going to have? Good, and they are what? Perfect. All right, does this have a horizontal asymptote? I don't know about the 0. A over B, good. Now, after you reduce, it still fits that general rational category. You can compare the original degree or the reduced degree. Either way, it's going to take you to the same conclusion. We're either going to compare 3 to 3 or 2 to 2. Either way, the degrees are the same, making a horizontal asymptote the ratio of the lead coefficient. Okay, Kai, does it have a slant? So domain, we're not going to be doing range. There's really no reasonable way to predict that with these. X and Y intercept, plug in 0 for X. Again, that's kind of messy. We're not going to go there. Horizontal slant asymptotes, holes versus vertical asymptotes. I think we're all good. I think that's about it for that. All right, how about number 6? Any volunteers for someone who hasn't done one yet? What do you got there? Tell me first the restrictions in a domain. All right, and how are you going to classify D? What's going on there? Perfect. Hole because they cancel. Okay, what would be your best descriptor of what's left here? Okay. And if we're going to classify it as a quadratic, we want to add that extra phrase after it. It's a quadratic with a hole. All right, how many x-intercepts does it have? Tell me what they are. Perfect. All right. Now, usually with quadratics, we'd like to know which way they open, up or down. Now, they told us that A, B, and C, D, A, B, C, D, etc. represent distinct non-zero integers. So they could be positive or they could be negative. We don't know. If A over B was positive, which way would it open? And if it was negative, good, that was the only other choice. But I try to trick you with that. All right, so as far as parabolas go, I mean, we could multiply it out, find a vertex. Not going to go there. That would be more than you have to know, but I guess that would be about good enough for number 6. I never wrote domain. How about number 7? Someone who hasn't done one yet? Any volunteers? Someone who has done one want to go again? All right, tell me, what are the restrictions in our domain?
And D.
Okay, tell me what's happening at C. And at D?
It's a vertical.
Perfect. They cancel, so it's a hole that does not vertical asymptote. All right, our remaining graph that we have still has the general rational flavor to it. So it would be fair game to ask the question, do we have a horizontal asymptote?
Two.
Okay, and what's it going to be?
0.
Perfect. Now, again, we can compare the original degrees or the reduced degrees. The original degrees, we'd be comparing 1 to 2, the reduced 0 to 1. Either way, the top is less than the bottom. That tells us the horizontal asymptote is at y is equal to 0. All right, does our graph have any x-intercepts? No, very good. The only candidate would have been x is c, but we've already said that's a hole. Once you're a hole, you're nothing else. All right, what else would be fair game here? So we talked about vertical asymptotes, horizontal asymptotes. Could it have a slant? Now, if it has a horizontal, it can't have a slant. We talked about there is no x-intercept. Y-intercept wouldn't be too bad here. That would be a over negative bd if we plugged in 0 for x. All right, I think that's probably good enough. What's our time check? Oh, good. We got through this pretty efficiently. All right, last one. Any volunteers? All right, tell me, what are the restrictions in a domain? Perfect. And what's going on at each of those? Very good. Nothing's canceling out. So this graph has 3 vertical asymptotes. That's a lot of vertical asymptotes. Okay, well, it definitely has that rational flavor. So it's fair game to ask the question about horizontal asymptote. Okay, does this have one?
Yeah, it's y equals 0 on top.
Perfect. And here, there are no like reduced, not reduced comparisons. Just the top of the degree of the top is 2, degree of the bottom is 3. Tells us y equals 0 is the horizontal asymptote. All right, how many x-intercepts we have?
That's easier.
Perfect. Range we can't really address. Domain, range, vertical asymptote. I think that's probably good. We'll wrap it up with that. Good job. All right, let me talk about real quick the homework. I'll pass it out to the people in class, give the people at home a chance to ask any questions, and then that should be it for today. All right, tonight's homework blends together a few different things we've talked about. So for the first page, for each problem, find all points of relative minima and maximum. Use the graph provided to sketch the function. If you're talking about minimums and maximums, typically, it's unlikely that you're going to find them without using a graphing calculator, that these are going to be graphing calculator problems. Get in your calculator, draw a reasonably accurate sketch, use the min-max features in order to get the mins and maxes. Okay, the next group, 5 through 8, you don't have to show the graph. You're looking for your intervals of where it's concave up, concave down. Okay, I picked graphs that should appear to be like cleanly symmetrical, where you think the point of inflection is where the point of inflection is going to be. There's not anything like deliberately tricky. Where it looks like it changes concavity, you can assume it changes concavity. Okay, the next group, the 9 through 12, you don't have to show the graph. It's asking you where it's increasing, decreasing. So for these guys here, usually what you'd have to do is find the mins and maxes, because in between the mins and maxes is where you determine where it's increasing, decreasing. And then the last group here, average rate of change. That's the slope of the line that passes through the endpoints of the interval. And then the equation of the secant line is the equation of the line that passes through the endpoints of the interval. Okay, this worksheet will wrap up everything you need to know for Thursday's quiz. Tomorrow will be a review, quiz on Thursday. Yes.
So like most of this all is like graphing calculator, like.
It looks like the first, these you can check with a graphing calculator, but you don't need them to answer those on the bottom. Yes. I don't know. I'll clarify. Whatever it says in Google Classroom is what we'll go with. What does Google Classroom say? Okay, then we could do Thursday then. Sorry about that confusion. Because that's where it actually marks it late if it's not in. So whatever that says, we'll default to. That's the more time than that, right? Okay. Any other questions? All right, those of you at home, let me just pass out the homework to the people that are here, and then I'll give you a chance to ask any questions that you might have. I think it's the Wednesday.
And that's next.
Yeah, so we're gonna have 3 days to review for the quarterly. It'll be Friday and then Monday, Tuesday.
And this is the work on.
Different review tomorrow. 2, 3. All right, for the people at home, any problems or questions, this would be the time to ask. If you're good with all this stuff, you guys can leave. We'll meet.
Hi, have a nice one.
You too. Thank you. Hey, Anthony, we just wrapped up class. So if you have any problems or questions, you can ask. Other than that, you don't have to stay on. Get home and